Hey everyone, and welcome back. Ready for another deep dive with us?
Always ready.
Today we're going to tackle something pretty mind-boggling. We're talking dark matter.
Oh, yeah, that's a good one.
Yeah, and we're using the astronomical minute as our guide. It's wild. It says something like 85% of the universe's matter is stuff we can't even see.
It's pretty crazy when you think about it like that. It's invisible to our telescopes, doesn't emit light, doesn't absorb light, doesn't reflect it.
Okay, wait. So if it's invisible, how do we know it even exists?
It's all about its effects. Like we can't see the wind, but we can see how it moves the leaves on a tree.
Right, right.
So picture this. Galaxies are rotating way faster than they should based on the matter we can actually see. The only way that makes sense is if there's something else there, something with a lot of gravity that we just can't see.
So it's like there's this invisible stuff holding galaxies together, right?
Yeah.
And making them spin super fast.
Yeah, it's kind of like an invisible scaffolding.
Pretty cool how we figured that out
Yeah,
just from how things are moving.
it is. And it all started way back in the 1930s. There was this astronomer named Fritz Zwicky.
Oh, yeah, I've heard of him. Wasn't he studying, like, clusters of galaxies or something?
He was, and he noticed something really strange. The galaxies in the cluster, they were moving way too fast. Like, based on what he could see, there wasn't enough gravity to hold them together.
So he's the one who first suggested there was this unseen matter out there.
Exactly. But, his ideas, well, they didn't really catch on at the time. It wasn't until the 70s that things really started to change.
Oh, yeah, Vera Rubin, right. I remember reading about her.
Yes. She was amazing. She very carefully measured how fast stars were orbiting within galaxies. And get this, she found that stars on the outer edges were moving just as fast as the stars near the center.
Wait, that doesn't seem right. Shouldn't the stars further out be moving slower?
Exactly. It just didn't make sense according to how we understand gravity. It was a major clue that something else was going on. Some invisible matter was affecting those speeds.
So that's when the idea of dark matter really took off.
Yep. Her work basically solidified the case for dark matter. It's like, okay, something's definitely there, but what is it?
Yeah, that's the big question. And I know scientists have come up with some pretty interesting ideas.
They have. One of the leading candidates is something called a WIMP.
A WIMP? What is that, like a tiny little ghost?
Well, not exactly a ghost, but close in a way. It stands for Weakly Interacting Massive Particle. So basically, it's a hypothetical particle that doesn't really interact much with normal matter.
So they're heavy, but they just pass right through stuff.
Pretty much. That's what makes them so hard to detect. It's like trying to catch a shadow.
So how do scientists even try to find these things? I mean, if they hardly interact with anything.
Well, they're getting pretty creative. They build these super sensitive detectors and put them deep underground
Underground? Why underground?
to shield them from cosmic rays. Those are high energy particles that are constantly bombarding Earth.
Oh, right, right. I remember learning about those.
Yeah, so they put these detectors deep underground to block out that interference, and then they basically wait for a WIMP to bump into an atom inside the detector. It's like setting a trap and hoping a WIMP stumbles in.
Wow. It sounds like a long shot.
It is, and it's not the only theory out there. There's another possible candidate called an axion.
Okay, Axion, that's a new one. What are those like?
Well, they're much later than WIMPs, and they behave more like a field that's spread out throughout the universe.
Okay, so we've got these like heavy WIMPs hiding out and these axions like permeating everything. Are there any other ideas?
There's one more, but it's a bit of a controversial one. Some scientists think we might not need dark matter at all.
Wait, seriously?
Yeah, they think maybe we just need to tweak our understanding of gravity. This idea is called MEN-ND, or Modified Newtonian Dynamics.
MEM-ND. So instead of some mysterious new matter, we just change how gravity works.
That's the idea. It proposes that gravity acts differently on really large scales. Like maybe it doesn't weaken as fast as we think it does over vast distances.
Okay, so that could explain why galaxies rotate so fast, even without dark matter.
Exactly. It's a pretty radical idea, but it does have some problems. It doesn't really explain all the observations we see, especially on the scale of galaxy clusters.
So it's kind of like a puzzle piece that fits in some places but not others.
Yeah, that's a good way to put it. The debate is definitely still ongoing.
Well, it sounds like there's still a lot we don't know about dark matter. But it's amazing how much we have learned.
Yeah, it's truly incredible, and it's all thanks to the dedication of scientists who are pushing the boundaries of our understanding.
Totally. But I'm curious, what kind of tools and technology are they using to unlock these secrets?
Oh, that's where things get really exciting.
Okay, I'm all ears.
Well, one of the most incredible tools we have is the James Webb Space Telescope. Have you seen those images? They're absolutely breathtaking.
Yeah, they're amazing.
The detail is just phenomenal.
It's like looking back in time.
Yeah.
But how does that help us study dark matter? It's invisible, right?
Right. But while JWT can't see dark matter directly, it can see how dark matter affects the distribution of galaxies in the early universe.
Oh, I see. So it's like we can see the footprint of dark matter by observing how galaxies are clustered together.
Exactly. It's like looking at a spider web. You can't see the individual threads, but you can see the overall pattern they create.
That makes sense. And I think I remember reading in the Astronomical Minute that scientists are also building some pretty incredible detectors here on Earth to search for dark matter particles.
They are. They're going deeper underground using even more sensitive materials like ultra-cooled crystals and liquid xenon to try and catch those elusive particles.
Wow. So they're really pulling out all the stops. But there was something in the Astronomical Minute that kind of made me wonder, what if, after all this effort, we never actually find dark matter?
That is a possibility. I mean, we have to be open to that. But, even if we don't directly detect it, the search itself is incredibly valuable. Think about all we've learned about galaxies and gravity and the evolution of the universe.
True. It's all about the journey, right?
Exactly. And, if we're wrong about dark matter, well, that just means we need to rethink our assumptions, and that could lead to even more exciting discoveries.
I like that perspective. So it's not like the game is over if we don't find dark matter. It just opens up a whole new set of questions and possibilities.
Absolutely. And who knows what amazing breakthroughs might come from exploring those new avenues.
Well, I, for one, am excited to see what the future holds for dark matter research.
Me too. It's such a fascinating and dynamic field.
Well, on that note, we've covered a lot of ground today, from the invisible scaffolding of the universe to the cutting-edge technology used to probe its secrets.
It's been a great discussion. And I think the Astronomical Minute did a fantastic job of laying out the complexities of this cosmic mystery.
Absolutely. And I can't wait to dive into part 2 and explore even more about this mysterious stuff that makes up the majority of our universe.
Sounds good to me. Let's see what other mind-blowing discoveries await us. It really is a mystery, isn't it? And the best part is, the search for answers, it just keeps going. And scientists are coming up with some seriously impressive tech to help us along the way.
See, that's what I love about science. There's always more to uncover, like peeling back the layers of an onion. So tell me, what kind of high-tech gadgets are they using in this cosmic detective work?
Well, one of the most exciting things lately is the James Webb Space Telescope, JWST. It's already changing how we understand the early universe. I mean, those images it's capturing, galaxies that formed just a few 100 million years after the Big Bang.
I've seen them. They're mind-blowing. Talk about a time machine. But how could it help us study dark matter? I thought it was invisible.
Good question. It can't detect it directly, but it can show us how dark matter affects the way galaxies are spread out in the early universe. Like, imagine you're looking at a spider web.
Okay, I'm picturing it.
You can't see the individual threads, right? But you can see the overall shape and structure they make. It's similar with JWST, we can see this cosmic web of galaxies and how dark matter has shaped it over time.
So we're kind of seeing the fingerprints of dark matter, even though we can't see the matter itself. That's pretty neat. So what about here on Earth? What are scientists doing here to solve this puzzle?
Back here, scientists are working on even more sensitive detectors, trying to actually see dark matter particles. Remember those underground labs we talked about to block the cosmic rays?
Yeah.
Well, picture those, but even more advanced. They're using some crazy stuff, ultra-cooled crystals, liquid xenon, all to try and pick up the tiniest interaction, even a whisper, of a dark matter particle.
Wow, that's dedication. But the Astronomical Minute, it said something that got me thinking. Like, what if we never actually find dark matter? With all this effort, isn't that kind of discouraging?
It's a possibility, for sure. We can't rule it out. But even if we don't directly find it, the search has been incredibly valuable. I mean, think about it. We've learned so much about galaxies, gravity, how the universe evolved, all because we're chasing this mystery.
That's a good point. So it's not just about the destination, it's the journey.
Right. Exactly. And hey, if we're totally wrong about dark matter, well, maybe we need to rethink what we know. Maybe our assumptions are wrong, and that could lead to even more exciting discoveries, right?
I like that way of looking at it. So it's not a failure if we don't find it. It's just like opening a new door to explore.
Exactly. Who knows what amazing things we might find if we start looking in a new direction.
Okay, I'm with you. But I got to ask, if dark matter isn't the answer, what other explanations are out there? I mean, We can't just ignore all the evidence that something's missing, right?
Of course not. And that's where things get even more interesting. Remember MOND, that idea where we tweak our understanding of gravity?
Yeah.
Well, if dark matter is a bust, then maybe MOND starts to look a lot more promising. Some physicists are even looking at some really wild ideas, like what if our universe is just one of many universes, and the missing matter is actually interacting with these other universes somehow?
Whoa, now that's some next-level thinking right there. So even if dark matter turns out to be a dead end, it's not game over. It's just a whole new set of puzzles to solve.
You got it. It's like the universe is saying, okay, you figured out that part, now try this one on for size.
Uh-huh. I like that. And who knows what kind of incredible breakthroughs might come from figuring out those new puzzles.
Exactly. Cosmology is full of potential, and whether dark matter exists or not, the search for it is pushing us to ask some really big questions about, well, about the nature of reality itself.
That's deep, man. It really makes you appreciate how much we still don't know about the universe.
It's humbling, isn't it? And exciting at the same time.
It's amazing to think something we can't even see could be so important, you know?
Yeah.
Like it changes how we understand everything out there. Makes you wonder what else is hiding in the universe.
It really does, doesn't it? And like they were saying in the Astronomical Minute, it's not always about the answer. Sometimes it's about the journey of getting there. Even if we never completely figure out dark matter, we've learned so much along the way.
Totally. Think about all the incredible stuff we've built. Telescopes, detectors, even the theories themselves. It's amazing what humans could do when we put our minds to it.
It really is. And I think one of the biggest things we've learned is that, we got to be willing to question what we think we know, be open to new ideas. I mean, look at the history of science. So many theories that everyone believed turned out to be wrong.
It's a good reminder that even in science, nothing is set in stone. Things are always changing as we learn more. Speaking of changing, there was this question in the Astronomical Minute that really got me thinking. What if, after all this, we never actually find dark matter? Like, what would that mean for our whole picture of the universe?
Whoa, that would be a huge shakeup, wouldn't it? So much of what we think we know about the universe depends on dark matter existing. If it doesn't, well, we'd have to go back and rethink some pretty basic stuff.
It'd be like, I don't know, having to redraw the map of the cosmos. But wouldn't that be kind of exciting, in a way? Like a whole new frontier to explore?
Oh, absolutely. It would be a chance to come up with totally new ideas, new theories, maybe even revolutionize how we understand everything. Like, if there's no dark matter, maybe those modified gravity theories like MOND suddenly start making a lot more sense.
And who knows what other crazy ideas we might come up with. Maybe there's some kind of physics we haven't even thought of yet.
Exactly. That's what makes it so exciting. The universe loves to surprise us, and this whole dark matter thing has really shown us that we don't have all the answers.
I guess it's like that saying, the more you know, the more you realize you don't know. But hey, at least we're asking the questions, right?
Couldn't have said it better myself. And that's really what science is all about, isn't it?
Curiosity, the drive to learn, to discover, even if it means admitting we were wrong sometimes.
Exactly. And that, my friend, is why we love exploring these topics with you.
Well said. So to wrap things up, maybe we don't have all the answers about dark matter just yet, but I think it's safe to say this whole journey has been pretty enlightening.
Agreed. I mean, we've learned about these invisible forces shaping the universe, about the scientists pushing the limits of what we know, and how important it is to stay open to new ideas, even if they challenge what we thought we knew.
Absolutely. Big thanks to the Astronomical Minute for taking us on this amazing ride. And to you, our incredible listeners, thanks for joining us on this deep dive.
Keep looking up, keep those questions coming, and never lose your sense of wonder. We'll catch you on the next one.
And remember, the universe is a vast and mysterious place. There's always something new to discover. So stay curious out there, and until next time, keep exploring.